We're on section 4 notes today. Hey, how you doing? Section 4 notes is all about factoring, which we've done, except we've not seen the sum of cubes and the difference of cubes. So I want to make sure that we see how those rules work. The perfect cubes, what are the perfect cubes? 1 cubed, 2 cubed, 3 cubed, 4 cubed, is that 4 times 4, 16 times 4, 64, 5 cubed, so forth and so on. If you can recognize those numbers, maybe even have a little list of them. I should maybe put a note, maybe in Google class about some perfect cubes, but you could look them up. And the rule is this: if you have a cubed plus b cubed, that factors into a plus b times a squared minus ab plus b squared. That is the most bizarre, and this right here will not factor anymore. That's a pretty bizarre thing. And the difference of 2 cubes is if you have a cubed minus b cubed, that's going to be a minus b times a squared plus ab plus b squared. Whew. So let's see if we can figure out how these work right here. Let me do number 7 for you, and I hope that you can remember that. I'm going to zoom in a little bit because I'm going to probably run out of space. Maybe I'll write this note down again. A cubed plus b cubed is going to factor into a plus b times a squared minus ab plus b squared. So we have to identify, first of all, what is our a, what is our b. This right here is the, maybe I'll do a harder one. No, I've already zoomed. This right here, we recognize that x cubed is x cubed. 27 is 3 cubed. So this right here, a is x and b is 3. A squared is x squared, b squared is 9. So if we have this as kind of like a key to things, we can drop things into here pretty nicely. So I'm recognizing that I've got a cubed plus b cubed in the form of x cubed plus 27. So this is going to equal, well, what is my a? My a is x. Plus, what is my b? My b is 3. What is my a squared? That's x squared. Minus a times b. What is a times b? That's 3x. Plus, what is b squared? That is 9. And that is my answer. Pretty neat, huh? Let's see if I can do maybe a more difficult one for the difference of squares, but the pattern will work very similarly. Yeah, let's look at number 12. Our rule again is a cubed minus b cubed is going to be a minus b times a squared plus ab plus b squared. And this is a great proof for why that works. I'll have to show it to you sometime. Do we recognize that this is something cubed and this is something cubed? I notice that there's nothing in common. The only thing that goes into this is 5, and 5 does not go into this, so there's nothing to factor out. There is something to factor out in a lot of the others. A 2 can be factored away from this. But the nothing factors out of here, so then I'm left with wondering, what cubed is 216? Well, it turns out that that's 6. 6 times 6 is 36, times 6 is 216. 6k is what a is. If you multiply 6k times 6k times 6k, you'll have 216k cubed. What am I multiplying by itself 3 times to get 125? 5 times 5 times 5. So b is 5. How about a squared? Well, if a is 6k, a squared is going to be 6k times 6k. That's 36k squared. And if b is 5, then b squared is going to be 25. So this is a nice key that I'm going to use to create that monstrosity up above. So this is going to equal, well, what is A? A is 6k. Minus B. What is B? That's 5. Times A squared. What is A squared? 36k squared. Plus A times B. What is A times B? That's 6k times 5. That's 30k. Plus B squared. B squared is 25. And that is my answer. Whew. The rest of this is stuff we've done before, and there are some good notes in the answer key packet that, of course, you can find in Google Class. I'll see you next section.